And I am live. And today is 28th of July 2025, Tuesday, right? Shit, today is Monday, my bad. And yesterday was a Code Forces contest number 1039, and it was horrible. My performance yesterday was horrible. I only solved a single question, and even that took me 15 minutes. A lot of things I did wrong before the contest and during the contest, and it affected me a lot in a negative way. And I have been thinking a lot about it, and I have come to realize that since I have chosen a target which is a bit, not a bit, quite a bit outside my level or range or whatever you would like to call it, and the target is to reach a rating of 2000 by the end of this year. That is 5 months, and currently I am at 1300. So I have to reach 2000 in 5 months from 1300. That is my target. And if my target is such, which is hard, tough, then I will be facing a lot of setbacks like this current one. And I have decided that strength is not how hard you can hit, but how hard you can get hit and then keep coming back. And with that, let's begin today's stream. And yeah, I came up with that quote originally. Pretty cool. Or maybe there was some old man who was talking to his son, and I eavesdropped on them and I heard what they were listening to, what they were talking about his strength, what true strength is. Yes, we are going to review yesterday's contest, even though I only solved. Yeah, see, my rating reduced. Yeah, my rating is down now. 70 points. Yeah, you can see the screen, I guess. Yep, you can see the screen. Yep, it went down 73 points. Yeah, pretty bad. Pretty bad. But yeah, it was my mistake. My mistake. I did bad and I could have done much better. I did bad. So let's begin contest. I could register. There is a contest on 31st, and like this is a single contest written twice here due to some reason. Shit, for this contest, my rating has to be above. Okay, there are two contests, Division 1 and Division 2. Okay, but we are talking about 1039 and just register there. That is cool. It is very fucking slow. Mm. And Emacs LS target contest, and this is question number B, which I was trying to solve, and this one is question number A, which I got right. The only question that I got right yesterday. And we will be going through these three questions today, and maybe even question number 4. Yep, question number 1. First of all, I will explain the question, then show you my solution for it. In the recycling center, there are n trash bags, and the ith trash bag has a weight of AI. At each second, two actions will happen consecutively. First, you choose a trash bag and destroy it. It will cost 1 coin if the weight of the trash bag is strictly greater than C, and it will cost 0 coins otherwise. Then the weight of each remaining trash bag will get multiplied by 2. What is the minimum number of coins that you have to get rid of? And this one is pretty cool. This one was nice. So let's say in this question, you have been given an array which represents weights of some trash bags. And yeah, so first you get the size of the array, and then you get a constant number, integer, C. And then the question is that you choose one trash bag in one operation and you remove that from the array, and you will be costed $1 if the weight of this trash bag that you have chosen is greater than this constant. And in this case, if we are choosing 10, then we will not be charged anything because the weight is not greater. 10 is not greater than 10, it is equal to 10. Therefore, we will not be costed anything. And second, all the remaining numbers will be multiplied by 2, which means you in this above numbers would become like this 8. If you were to choose 10, then the array would become this. And then you choose one more thing again, and let's say you choose 2, then you still would not be costed anything, and this would become 16, 60 and 32. And for these, since they are like never going to be smaller than 10, then you would be costed 3 coins, 1 coin for each. So for this, if you are choosing these in this specific order, then their cost would be 3. Now you have to find the smallest cost, right? So my solution first takes in the array and then sorts it. So you have some number here, then 4, 8, 10, and then 15. After sorting, my solution starts a loop from the end till the first element, and it goes to the left. And also I have a variable called rem, which has the number of bags which are remaining, and initially it is equal to n because I have not removed any bag. So, and then I start iterating from the left, and I go from 15 to 10, and I find the first element that is smaller than C, that is in this case 8. And why am I looking for the biggest element that is smaller than the constant? Because if I were to choose any other element, then this one has the greatest chance of getting above this C range, and when that happens, this I will be costed 1 coin for this bag also. But if I were to choose this right now, I would save that cost, and for all the elements to the left of this, I would be costed $1 anyway, so that is fine. So I need to choose this one because this is at the brink of getting greater than 10. So after I choose this, I do rem minus 1. Rem minus 1. Rem becomes equal to rem minus 1. Since I have removed one element, so I have one less number to one less bag to remove. After choosing 8, my array becomes 2, 4 becomes 8, 10, 20, and 15. And I am, well, technically, like specifically, this also becomes 16. And there is one thing that I'm doing to keep track of how many times I have multiplied the array. Like I am, whenever I remove this thing, I am also keeping a shift counter SHFT, which is initially equal to 0, and I am, whenever I'm checking an element, comparing it with the C, with the C number which has been given to us, I'm shifting that number by shift amounts, which means I am multiplying that number by 2 a specific amount of time. And initially, when I compare 8 with 10, I have left shifted 8 0 times, which just gives me 8. So that is cool. And when I decrease remainder by 1, that is when I am choosing a number, I decrease remainder by 1 and I also increase shift by 1. So next time when I will be checking any number, in this case 4, I will left shift 4 by 1 time because shift's new value is 1. So left shifting 4 by 1 time makes it 8, and comparing 8 with 10, 8 is smaller. So I increase shift once more, and I reduce remaining elements by 1, and then I move on to the next element, which originally was 1 and it still is technically 1, and I left shift 1 with shift's current value, which is at this point 2, and left shifting 1 twice makes it 4, which is also lower than our 10, which is our C in this case, and this, so I can choose this without using any remaining points. So remainder becomes less than 1, and we have reduced remainder 3 times, once for this, once for this, and once for this. And initially it was equal to 5, which was the total size of the array. So now it is 5 minus 3, that is 2, and 2 is the number of bags that whose cost we would have to pay, and the cost is just the number of bags because $1 for each bag. So the minimum answer would be 2 in this case, and for the first one it is equal to 2, and that is exactly what I have written in my code. I take in n, I take in c, then I create an array, and then I take in input into the array, then I sort the array in reverse order, and answer initially 0. And actually I don't even have to do this. I don't need an answer variable there. Remainder initially 0. I don't I don't need I here. I'm defining I here, and shift initially 0. And yes, and then I simply iterate from left to right, that is from the bigger elements to the smaller elements, and I find the element that is smaller than I, and if I do find it and it is still inside the range, I reduce remainder by 1 and increase shift by 1, and do that again and again. At the end, remainder is my answer. And I think this should be the best possible solution for this one. And I got it right in first try. Greedy and sorting. Yes, I am doing greedy and I am doing sorting. Let's see the tutorial. Let's say a bag is expensive if AI greater than C, and free if this. Okay. First, observe that as long as there is at least one free bag remaining, we should destroy a free bag. We will perform all expensive destructions at the end. The goal is to perform as many free destructions as possible. When there are multiple free bags, which one to choose? Yep. The bigger a bag is, the less time you have to destroy it before it becomes expensive. Hence, at each second, you should destroy the biggest remaining free bag. That is what I do. This process can be natively naively simulated in n square time which was sufficient under given constraints if you sort the array beforehand and keep the current multiplier in a separate variable instead of multiplying all current multiplier in a separate variable. It can be done in n log n time. Yes, that is how I did. And I am read the problem. Yeah, it was amazing. I would like to see the code that they have written. Okay, they have, okay, that is what they have done. Linked to someone's submission. So taken C and N and vector of long called A, N, and for LL, yeah, it has taken the input and then sort in a reverse order, saved equals 0. So at the end, I go with the remainder, they are doing increasing saved. Okay, and multiply this, saved. Okay, that makes sense actually because I could replace remainder and shift by a single variable. So I don't actually have to do this, not even this. I can do n minus shift, and instead of shift, I can call this save. Uh, a better approach, CW, saved. Okay, these are Vim things. CW saved, and this should also give me the correct answer, which it does. So yeah, this was cool and a little optimization. So wouldn't matter if I give my submission what I wrote or what they have written. And now moving on to the second question, which I was unable to do. You have to create another array by choosing left or right elements. You are given a permutation, and yeah. So in this case, in this question, let's choose this. You are given a permutation, let's say like this, and given a permutation of array A in any some order, and there is an array like this is considered good if it is not bad. And what is a bad array? A bad array is such in which you have 5 consecutive elements which are sorted. In this case, these 5 consecutive elements are sorted in ascending order, and they do not have to be exactly in ascending order. If this array was in reverse, 7 6 5 4 3 2 1, it would still be considered bad because there would be this again, this sequence from 5 to 1 in descending order. So that is considered bad. And you are given an array A, and at one point you have to choose, at every point you have to choose one element either from the start of the array or from the end of the array and add it to another array, and then you will be left with this much, and this, and then you choose one more element, you will be left with this one. You choose one more element, you will be left with this one. You choose one more element, you will be left with this one. Then you choose a few more elements like that, and you will have another array, and this array will be called Q. And you want to do this choosing operation in such a way that this resulting new array is good. And how will it be good if it is not bad? And what is bad? Bad is when there are at least 5 numbers, 5 consecutive numbers which are sorted in either ascending or descending order. And one more thing, that this starting array is a permutation. That is, the size of the number, the size of the array is let's say the size of the array is n, so this array will be formed with all the integers from starting from 1 to n. Here the size is 7, and this array has all the numbers starting from 1 to 7, and the order could be anything. And what do I have to output? I have to output a sequence of left, right in a way which depicts my choices of these numbers which I am choosing from the end every time. And after performing these operations, my end array that I get, the Q array, it should be good. And yeah, I was unable to do this question. I was thinking about how I could go about achieving this thing, and I was unable to do that. Yeah, pretty horrible. So I will simply go to the solution because I have maybe not done my best, but I have given my time. Instead of taking either the leftmost or rightmost element, think about taking either the minimum or the maximum element. Okay, it is possible to ensure that. How is it possible to ensure this greater, smaller? How is it possible to ensure that? I mean, in this case, it is not possible to ensure that, right? Because let's say my Q array is empty at the start and I have some A array in which I have two numbers a1 and an at the end, and since it is a permutation, a1 is not equal to an, so one of them is smaller than the other. Let's say a1 is smaller than an, so let's say I choose a1, and to prove this I would have to choose a number that is greater than a1. And right now this next number which I get here, a2, it could be since I know that uh, a1 is smaller, that is what I said, but I made the wrong symbol here. a1 is smaller, so we had this thing, an is higher than a1. Now this a2 number, it could lie either here, a2, or it could lie either here, a2, or it could lie either here, a2. And to make this a next number has to be greater than a1, and it will be greater than a1. It will be, could be an or could be a1. Now depending on where a2 is, a2 could be here, a2 could be here, or a2 could be here. And since I want the next number to be greater, if a2 is here, then I would be forced to choose an. But if a2 is here or here, then I could choose either an or a2. And if a2 is here, let's say, then I choose an, let's say. So now I know that a2 is smaller than an. a2 is smaller than an, and I would have a new number, an minus 1, which could again be at any point in this series. I've chosen an, and now the next number I want it to be smaller than an. And wait, shit. The next number, I want the next number to be smaller than an. And since at every point I have one number here at the start and one number at the end, I choose, let's say, the smaller one of those, right? And a1. So next I have to choose some number that is greater, either an or a2, which is the next number from the start. and I know at least one of them is smaller, is greater, and now either a2 is greater than an, or a a2 is less than an, or a2 is greater than an. And whatever the case, I choose the greater number, and I choose the greater number, in this case this, and in the other case this, and then I would be guaranteed to have a smaller number after making my choice, and thus this thing is always possible. So that is cool. And if you were to look at my solution, which I have written, it is horrible, goes up to 96 lines due to some reason. Here, here. And yes, I have changed my setup a bit. I will be coding like this from now on. In code forces, at least, I will be coding like this with my terminal on the right and everything on the, with my terminal code writing on the right and my browser on the left. But this hides my bookmarks, which I want to see. I want to see the Vim and the code forces bookmark. So I can remove everything else. Yep, not free VPN. Yeah, this is cool. I have still access to this one. That is cool. So I can solve this question like this. How is the input? Int n, right, and cn n, and then a vector, yeah, via n, and for auto x na cna or cnx, and then in L and R, and I have L equals 0 and R equals n minus 1, and while L lower than R, I will, okay, and bool greater true, let's say, and then if gr, then I am looking for the greater element, and cout depending on L and R. L, not L, AL. If AL is greater than AR, then output L, else output R. If I'm looking for that, and I will start with this equals false, and I think I don't even have to check this. I can simply do if this thing equals gr, and then gr not equals gr. Yeah, gr equals not gr, and cout a new line. So that work, I mean, I have implemented what was in here. Okay, it keeps on running due to some reason, because yes, I would have to do, yeah, I have to increase an L and R. Yeah, shit. Okay, so if a L smaller than AR equals GR, and that is if I'm looking for greater, and if I'm looking for greater, and this thing is, these both would be true if I'm looking for greater and AR is greater, then I would print AR. And also, if this is false, that is, I am looking for false, and this is also false, which means that AR is not greater, AL is greater. So I will print out R, in which case I simply do this. Output R and R minus minus, else out L and L plus plus. Yeah, and yeah, always do this. Let's see, and wrong answer, but that does not matter. Left, right. I guess this should work. Yeah, select everything, go here, submit code. This is very slow. Well, it is not this slow during the contest. During the contest, it is a bit faster than this. And do you see this? This liquid glass display. It is more apparent around with some background. See, liquid display. This is a new feature. Mac OS 26 release beta version, and this cool thing. Like, this is fucking amazing. And yeah, just Mac beta version. And submit. Running and wrong answer on test 1. Wrong answer on test 1, it says. How is that? Shit. It is not working. Yep. Click. Wrong answer on test 1. Doesn't correspond to pattern this. Right. Equals LR, LR, LR. Doesn't correspond to pattern size. Okay. Am I outputting? Yeah, I am. The length of strings is 1 lower. Okay, when they are not equal, but even when they are, okay, I will get out when they are both equal, and at the end I can output right or left, it does not matter. So um, change this, change around single quotes, make it double, and let's go left and new line. Select everything and output this thing. I guess I can make this a bit smaller so that I see this thing properly. Do I see this thing properly? Nope, still not. It is accepted now. Why don't I see the test case submission properly? It is being cut off from the left. What can I do to solve this? Zooming in and out does not help. I guess I will see that. on my own time. So we did that. And in the third one, this one was cool. And I think I would have been able to do this. What do the tags say? Constructive algorithms. Okay, that is something that I would have to look up. Sorting, I did not do sorting. So why would I do sortings? I did use two pointers, which was apparent because I had to choose numbers from left and right. And greedy. Okay, I would have to look up constructive algorithms. That is one thing which I have taken from this question. And the fact that these were permutations. The original array that was given to me was a permutation. And there are special things you have to pay attention to when you are using a permutation. Now, leftmost below, but before moving forward, I would like to see submissions made by the top ranking person. This guy, this guy, and the submissions for this one, DQ process. Okay, shit. It is just simply not rendering. If I click on it now, it is rendering now. Okay, I guess it is the way it is happening because of the way that they summon this thing out. And what is he doing? Taking in, right? Then a vector, taking in the input array, string answer. Okay, he is creating a string for the answer. And he can creating a string of size n is less expensive than creating a vector of the same size, because in a string every character is 8 bytes, and in a vector integer you might be using long. Yeah, I am using long at least. And then two pointers, left and right, and previous is 0. Now while less than and equal to, if it is equal, then just put in L. Else if it is not equal, then that is L is to the left. Then if previous, okay, yep, taking and okay, so previous is working as gr in my case, and he has done exactly what I have done, so that is cool, even though for him it took him how much time on tests. I had to look up this thing. Okay, contest is not showing up here, but I can go to the standings and see how much time it took him. It took him, okay, 2 minutes for the first one and then 4 minutes for the second question. It took him 4 minutes to do the second question, and it took me 15 minutes to do the first question, and more than a day, about a day, and after reading the tutorial to do the second question. So yeah, there is a gap. There is a bit of a gap. And now leftmost below. What was this? Consider an array. Okay, initially I is 0 for every I. You can do operations of the following form. You choose an integer x greater than the minimum ai. Okay, greater than the minimum value of a, and then I is defined as the minimum index such that ai is greater than x. The minimum index such that ai is greater than x. The minimum, that is everything to the left of is ai is lower, smaller than x, the smallest index, which means that everything to the left of ai is greater than x. In other words, I is a unique integer between 1 and n inclusively, such that I is smaller than x, and for every j is equal to or greater than x from 1 to I minus 1. Finally, increment ai by the number x. And I didn't understood like how I understood the problem, but when you are doing this operation kind of thing, some things are there which remain constant over every operation or change in a very predictable manner, so that you do not have to go through and simulate everything. But in this, I didn't know. And at the end, I will be given an array and I have to tell, and can this array be formed by these operations? So I had to figure out something that does not change over these operations or only changes in a very particular manner for the size n. And if that thing is still the same for these final arrays, then they could be derived from the original array, which contains zeros. Otherwise, no. And just a greedy algorithm, I don't know. I would have to look for at the tutorial for this one. CF rating, what's your rating of CF? It is right now 1230. It like, yeah, yesterday it was more, now it is lower. The first time that I have lost rating in a contest. Try to come up with a sufficient condition first, then prove it's necessary. Doing some examples with N3 might be useful. Okay, that was my thought, but yeah, the main thing yesterday was that I just didn't go through. I lost my stamina. Yep, I just didn't go through with what I was doing, and that was a problem. And let me try to think of that thing that does not change over time. They are saying to work with n equals 3. So if n equals 3, initially I will be having this array. And with this, the minimum value is 0. And I can choose any number above the minimum, that is any number from 1 to like anything, right? Any number x from 1 to anything. What is the greatest value of x that I can choose? You can choose an integer greater than a minimum value of a. So no limitation to x, no limitation to the highest bound of x. So whatever I choose, I know that this thing will be converted to x, because this is the smallest index which is smaller than x, which is that is 0. So I make this equal to x, and these are 0 0 again still. And then still I have a choice to choose any number. Now I have two choices. Either I could choose x again, I could choose a number that is greater than x, or I could choose, let's call this x1. I could choose a number that is lower than x2, the next one. And if I choose a number equal to x, then this one will be converted to x. And if I choose a number that is greater than x2, this one will be converted to x2. So now this one would be converted to that, to x2. Okay, x1 plus x2, x1 plus x2. And if I choose a number that is smaller than x1, then this thing will be converted to x2. So in two cases, this value changes, and in one case, this value changes. And the case when this changes is when I choose a number greater than this number. And what is the thing that is still constant? And is there a bound to these two? If I choose, okay, so if I want to increase the next number, theoretically, here I could choose a number till infinity, starting from 0 till infinity. I could choose any number. But if I want to increase x, I have a bound. My x2 has to be greater than x1. Only then can I increase x1, and I can increase x2 only this second number only when this number the x2 that I choose is smaller than or equal to x1. Only then can I increase this number. So does that help me? How does that help me? After doing that, so can I, mm, given an array, figure out if these conditions hold? If I can do that for every pair, then we would be cool. So when going through the array, I might see three types of pairs in ascending order: equal, or greater than, or and smaller. And in this case, this is greater than this. In this case, it is equal, and yeah, so this is, I guess, this could have, let's talk about this first. This could have arisen when I, let's say, had this thing. I am supposing that the first one in every one of these, I am given, like it is always possible to get the first one because I will be starting from the first start, and this starting number, no matter how big or small or whatever its value is, I can always have that by choosing the my initial x equal to that number. So I can always get this first one in every pair, and whenever I move to the next pair, I will only move if I know for sure that I can achieve this number. Okay. And okay, so in this condition here, I could have reached equality if, first of all, I was at 0 and then I chose, let's call this x again, then I could have reached this. Or if I was at some value and then I chose a number smaller than x, in which case also this would have happened. So that is cool. That is cool. So when they are equal, it is always possible to have them equal. And when they are not equal, either the second one is larger or the second one is smaller. And given, let's talk about this case when the second one is smaller. When the second one is smaller, initially I could have started at 0. Let's call this x1 and this x2. If I was at 0, I could choose x2 and x2 would be added here and I would have the given sequence. So that is possible. Or I could have had some smaller number and then chosen a bigger number to make this. So in that case also, so it is always possible to have this greater to smaller jump. But in this case, when I have something like this, a number here and x1 and then a number here x2, and let's call their difference surprisingly x1 x2 minus x1, that is their difference. So whenever their values are different, what is the maximum value of this x2 thing? x2 minus x1. What is the maximum difference? Let's say I'm initially at 0. I'm initially at 0 for this x2 place, and the maximum value that I can choose then would be x1 minus x1. x1, let's say I choose x1, and then second, then the maximum value which I can choose to make x1, to add some number to x1, would be x1 minus 1. No, if I choose x1 minus 1, then uh, I can then choose any number. Shit, wait. Every number to the left of it has to be greater. No, has to be greater or equal. And yeah, the number that I'm adding has to be greater than this. Yeah, sure, sure, sure. So I have to choose some number that is greater than x1. So yeah, choosing x1 would not help us because then we would never be able to add anything to x1. So choosing x1 is bad. So let's say we choose something lower, x1 minus 1. And the next number that we have to choose has to be greater than x1 minus 1. And so that is the lower bound, and the upper bound, so that we do not add it to x1, is x1. So the greatest number we can then choose is x1. So the maximum height the second number can have is 2x1 minus 1. 2x1 minus 1. That is the maximum height a number can have. So if I see a condition like this, when the next number is greater, that is they are in ascending order, then if x1 is my current number, then the next number cannot be greater than this. It can be equal to this, but not greater than this. And I think that would be the correct thing. I've not read the whole thing. I only read this much, which I like the half part, sufficient condition. I knew this part before reading this, but no point in justifying since I was unable to do this during the contest. So let's go. What the heck? Still inside Vim, what the hell? And yep, lazy update. Updated and okay, key maps, boilerplate 35. Why is it so big? Okay, boilerplate this much, and then in n, take in n. After taking in n, I will take the whole array, and I yeah, I'll just take in the array instead of computing the answer while taking in the input. Auto x a c in x, and then for in I will start at 1 and less than n. I am starting I at 1 because whatever the value is for the first element, I could always have that. And now I have to compare the current element with the last one. So if and bool possible, we are supposing that possible is, so if a I is lower or a has to be lower than 2 into ai minus 1. If it is lower, then cool, but if it is greater than or equal to this thing, then P equals false. And one more thing, break. And then if P, then C out, yes, and else C out, no. Let's see, and wrong answer. That is cool. I do say yes in this case, even though I should say no in this case. Here, the next number is 60. 60 is possible. 40 is always possible, let's say. And then here, I could, the maximum value that I could get here is this. And if the next number is smaller, the next number is actually greater than this. So let's say I choose 40 here, then I choose 39 and then some number to make this equal to 60. But then how I could have chosen 90? Wait, this is possible, right? 40, 60, 90. This should be possible. 40, 60. I want to reach 40, 60, 90. And initially I start with 0, 0, 0. And in first step, I make this equal to 40, which is possible. And in the second step, 40, I make this equal to 39 and 0, which is also possible. And then I make the next number to make it equal to 60. I choose 21, but I cannot choose 21. Okay, that makes sense. I cannot have 60 there. Yep, I cannot have 60 there. Okay, so the range for this next element, if it is greater than 40, is not linear. Let's say I had chosen, so yeah, this analysis was a bit off because when I choose this x minus 1 as the first element, then x is the only element that I can choose. Not that I can choose any element between 1 and x1. I have to choose x1. So I could have 2x1 minus 1 there, and if I had chosen the next smallest, the next greatest element I could have chosen was this x1 minus x2, in which case here I have a leeway of choosing any element. The element that I am choosing has to be smaller. The element that I am choosing has to be greater than this, uh, and smaller than x1. And how many numbers to fix that are in that category, smaller than or even equal to x1. And the numbers that fit that category are x1 minus 1 and x1. And if I choose, let's say x1, then I would get 2x1 minus 3. And if I choose x1, I would get 2x1 minus 2. So I am getting all of these numbers, which is cool. and I can extrapolate this thing, and then I could choose x1 minus 3, let's say, here. Then the next number that I choose has to be, wait, but the range, yeah, I could have chosen anyway. Yeah, 2x minus 1. So my final number on the right can be 2x minus 1, 2x minus 2, 2x minus 3, and let's see if it extrapolates. So the next, if I choose x1 minus 3 as my first number below, I can add it there to 0, and then the next number has to be less than or equal to x1, and numbers that fit this category are x1 minus 2 and x1 minus 1 and x1. Okay, so I reduced this by 1 and increased these by 1, which gives me x1, 2x1 minus 5, 2 x1 minus 4, and 2x1 minus 3, 2x1 minus 3. Okay, my range is still ongoing. I can choose any number. So in that case, when I was choosing, when I had to make 60 out of 40, I need 40, 60. Okay, so which is 2x to for 2x minus 20. How do I reach sum of 2x minus 20? Minus 3, 4. I could choose, I guess, 2x minus 9. Okay, 2x minus 20. Is it not achievable? I had, I would have to do 2x. Okay, 4. 4 is achievable here. How? When I am choosing x minus 1 and x minus 3. So yeah, I could choose as my first number x minus 10, x minus 11, and then as my second number x minus something greater than this, x minus 9. So after 40, I could choose x minus 11, which is 29. So this becomes 29, and then shit, since I'm supposing all of these are equal to 0. Yep, that is a problem. Since I am supposing all of these are equal to 0, so I cannot make this infinitely big. To choose a second number after this, that I can only choose a second number after, yeah, I cannot choose a second number after this. Shit. Which would add directly to this because I'm supposing that everything else is a 0. So in one go, the highest I can go is equal to the last value, and if I want to go higher than the last value, I would have to see, let's say I get 40 in here. Nah, I guess I would have to see the solution. So yeah, I was unable to come up with this. Let's mi be the minimum. Okay, for every I between starting from the second element, because first we can always achieve. till the last we can compute in which can be computed in linear time. Yes, we claim we can achieve A equal to B if and only if BI MI is the minimum. We can make A equal to B if and only if the current value minus the current minimum is lower than the minimum. Is lower than the minimum. For every element, it has to be lower than the minimum. Lower than the minimum. How? Prove that it is sufficient. You can build the array from left to right for every I, bi lower than the initial minimum value. We can directly add bi, but we cannot. Okay, if it is lower, then we can directly add bi. Otherwise, we first add bi minus minimum and then mi. How? Proof that it is necessary. We can build the array from left to right for every I if bi is smaller than mi. We can add it directly. If it is smaller than the current minimum in the array that has been given to us, otherwise we first add minimum and then mi, bi minus minimum. In this case, it would be adding 4 first of all and then this, then I, which does work. And in this case, I would have to, the current minimum is 1. I add minimum, which is 1. This value, that is 5, and then the minimum 5, and this I can add 5 and then the minimum. Here I can, it is minimum equal to minimum. I can just add 1 1. How is this thing working? Yeah, I'm not getting this thing, this part. For every element in the given array bi, I subtract the minimum, and that difference cannot be greater than the minimum. That is, let's say this height, this is the height for our minimum element, and I have a lot of elements, a lot. And they are saying that for every element, starting from the second element, if I see the difference between that element, let's say x, and my current minimum, this difference cannot be greater than m. This has to be lower than m. This difference has to be lower than m. And if I have something truly humongous, then that difference is greater than m. And we would say that this is not possible. But why is that? And this proof, I do not understand the proof, even the proof. This is kind of sad. We can build the array from left to right for every I that is smaller than mi. Then we can add bi for every I. If bi is smaller than mi, then we can directly add bi. But how? Let's say I have an array 10, 5, 3, 3, and 3 is the minimum. Okay, this is like not lower than bi, so let's reverse this actually. 10, 3, 3, 10. Okay, minimum is the smallest. Minimum is this, minimum is this. Wait, how would any number be smaller than the minimum? If bi is smaller than mi, then how would it be smaller if mi is the minimum by definition? Mi, minimum of all the elements from a number till that number. Okay, okay, okay. And if it is smaller, then we can simply add it. Makes sense, makes sense. This thing now makes perfect sense. For every I where bi is smaller than this makes perfect sense. I can add it simply. And otherwise we first add bi minus minimum and then mi. So if it is smaller, yeah, then we can simply add bi. And this was the case, right? Which was wrong. 40, 60, 90. We start iterating from this thing. And we see that this is greater than the minimum till now. Than the minimum till now. Let's take a bigger example. 5, 6, 1, 1. We have this thing. Then we start iterating from the second element, which is this, and till now minimum is equal to 5, and this thing is greater than the minimum. So to get that, I can first of all, of course, take the minimum. But they are saying take minimum bi minus minimum and then the minimum. Bi minus minimum and then the minimum. That is this thing minus minimum. This thing minus. So yeah, this thing is some b2 minus b1. b1 is minimum. This thing plus that is, let's say this is 5, this is 6, this is 1, and this is 1. In this 5 and 6, this bigger one constitutes of two things, two numbers, this and this. And they are saying to choose this difference first and then choose this. So I added 5 initially, and then the difference between 5 and 6 is 1, so I add 1, right? And I will add 1 to this thing, which makes sense. And then the next number that I have to choose, which I can actually choose given that everything else is 0, that number has to be greater than this. Yes, that number has to be greater than 1 and smaller than this. And the maximum that I can choose smaller than or equal to this is 5, which makes it equal to 6. Okay, and what was the mistake that I was doing earlier when I was doing all of this thing? I chose 40, then this, and then I thought that I should choose, no, there were zeros, right? So 29, and the next I was choosing some number that is greater than 29. I had to choose some number that is greater than 29. 29 x minus 9 plus x minus 9, which, yeah, I could choose 31, and this would make 60, so that is cool. 40, and I would get 60 here. That is one way to get it. Okay, so this much part of my solution was correct, right? I could choose 31. Yes, because 29 is the smallest index that is greater than, that is smaller than 31, and everything before that is this. Okay, so I get 60 and 40. Okay, so I have to substitute this thing with that. Okay, okay, makes sense. Then 90. How could, if we had only this much array, then I would be able to get 90, but we cannot. If I choose a number that is greater than 40, then it will be added to 40. So I must choose a number that is smaller than 40. And the maximum that I can go with 40 as the range is 80 minus 1, 79, and here 90 is greater than 79. Okay, okay, makes sense, makes so much sense. So instead of comparing it with this, I will be doing min equals a0, and I can do a0 here because I know that n is at least equal to 1, so a0 does not, a0 is not bad. So instead of comparing this with this, I will compare it with n and then subtract 1. Uh, and if not this, then this, and after every iteration, min changes to the minimum value. After every iteration, min equals minimum of mn and the current value. Okay, it does give the correct answer here. Let's see if it is actually correct. That would be cool to see. Choose the problem number 3 leftmost below, submit. That is accepted. That is cool. So what is the thing that I can take away from this? Yes, I would have been able to do this during the contest. I don't know, my mind was not working clearly. Yeah, I should have been able to do this during the contest. And the one insight that I missed was this: when I was during when I was doing this comparison, I was only focusing on these two elements, the current pair, but I had to focus on the minimum element till that point. Yep. That and proof that it is necessary. Let's read that. Proof that it is necessary. Suppose we manage to reach B at every step, AI, which is great. Okay, yeah, BI for every I. Consider the last operation X that incremented AI. Consider the last operation X that incremented AI. Then, by the definition of AI, we must have had the last operation that incremented AI. Okay, so we are supposing that AI was the last number that was incremented. We must have AI has to be smaller than X, and X has to be greater than the minimum. X has to be greater than the minimum in AI and either equal to or lower than the minimum in BI. Cause are we always updating the AI is lower than X, that we know. Am I always adding to the minimum number? I'm always choosing a number that is greater than the minimum number, that is greater than the minimum number. And how many numbers are greater than the minimum number? I'm adding either adding it to the minimum number or a number that is between the minimum and that. And if in both of these cases, the minimum, if I'm adding to the minimum, then the minimum of BI would be greater than my minimum was in AI. But if I'm adding to some other number, then the minimum would remain same. So this thing is true. This thing is true, but what does it lead to? Hence, BI equal AI plus X. Yes. And this has to be lower than or equal to 2x minus 1, which is lower than or equal to 2mi minus 1. Minimum to the left of it. X has to be smaller than the minimum to the left. Yeah, X has to, X has to be smaller than the minimum on the left. Yes, X has to be smaller. This thing makes sense. And this thing also makes sense. AI plus X. That is what I am doing. And BI has to be between 2x minus 1. That is what I did. 2x minus 1, which has to be in, minimum 2 into minimum minus 1. Like, if it is greater than this, then false. Okay, I'm not totally satisfied with my understanding of this, but okay, I can move on. Was this like 3 blue, 1 brown? This is blue. And now what? It's been 1 hour 22 minutes, and I would like to now solve some questions on CP31. Okay, I have not done these two questions. Let's try to do these 1100 rated questions. You are given an array A of n positive integers and A is score. If your score is greater than or equal to AI, then you can increase your score AI by removing, then you can increase your score by AI and removing AI from the array. For each index I, output the maximum number of additional array elements that you can remove. Okay, I can increase my score. If my score is something, I can increase my score by removing any element. Okay, AI will be added and AI is greater than or equal to. So to remove the maximum number of elements, I would like to remove the smallest element first, because then my score would increase the smallest amount that it can. For each index I, output the maximum number of additional array elements that you can remove if you remove AI, and then set your score to AI. Okay. Okay. Let's do go to CP, and yeah, this thing, I have this below in the bottom, and yeah, I was trying to do something with that. We'll Pain, CD 1100, NB collecting gains, not this, but this one. And I can hopefully remove all of this code. Yep, and then work in here. End and scene and then do I need, yeah, I will just export A for auto reference X and A, P and A, not A, X. And then after taking the input, if I choose the ith element for int I equals 0, I less than n, I plus plus, I plus plus, and so my score it starts at AI. I think I have to sort this thing first. Yeah, sort it SR size n and iota all SR starting with 0 since it is 0 indexed, and then sort all SR with a reference function takes an int I and int j and return AI lower than AJ. Right, and now it is sorted. So if I choose index I would know how many elements are smaller than I, and I can actually traverse through them. And shit, the time complexity would be about n square. Can I afford that? N square, n square. Can I afford n square time complexity? I think something related to dynamic programming. It's okay. Let's say I have, okay, shit. Very long array. Yeah, size is cool. Let's say I have this thing. If I have this thing and then I sort this, and this becomes, after sorting, this becomes 1, 2, 4, 5, 20, and 20. So if I choose one, how many elements can I remove? The only elements that I can remove with one would be the elements whose score is greater than 1, right? If my score is greater, so yeah, nothing. For this answer is 0. If I choose 2, I have at least one element that is smaller, and when I do that, my score becomes equal to 3, and yep. So I remove 1, 2 was already removed. I have 3, and my score is not greater than 3. So answer for 2 would be 1. For 1, it is 0. And for 4, initially, oh, yeah, initially, my score would be 4, and I would go to the smallest element because that would increase my score the smallest amount of time. I remove that element and make my score equal to that. And to remove an element, my score has to be greater than or equal to AI. So I first remove 2. That is the greatest element, so because I want my score to be as great as it can be. So I remove 2. And when I remove 2, my score becomes 6. And then what is the greatest element? It is 5 that I can remove. So I remove 5 and my score becomes 11. And now my score is 11. The greatest number I can remove is 1. So my score becomes, after that, 12. And then I cannot remove any other element. So for 4, I removed 1, 2, and 5. That will be 3. And when I begin with 5, my score was initially equal to 5. My score was initially equal to 5. And wait, let me remove uh, this stuff. My score was initially equal to 5, and the greatest element that I could remove was 4. So I removed 4, my score became 9. Then the greatest element I can remove is 2, my score became 11. Then the greatest element I could remove is 12, my score became 12, is 1, and my score became 12. And still I was able to remove only 3 elements. And when I am at the last element, I can remove all of these elements because my score is always greater than them. So what I have to check is, okay, for 4, I start with 4. The maximum score that I can have is when I remove all of these elements, right? So accumulative sum, which would be prefix sum. The score I could have here would be 7. And then I move to the right and check how many more I can remove and keep adding that on also. And if I do that, prefix, shit, 7, okay, 1, 2, 4, 5. I have to do something with prefix. Here the prefix sum is 1, here the prefix sum is 3, here it is 7, here it is not 9, here the prefix sum is 12, and here the prefix sum is 22. And at any number, I know that I can always remove all the numbers to its left. So the maximum prefix I could have is 7. And when I am at 4, I have to see 7 is greater than 5. And when I do that, I get at prefix this. So, so what does this mean? If I start at 1, I cannot remove any elements, so 0. Then for 2, my prefix is 3, and 3 is smaller than the next element. So maybe I can start with 20. Here the prefix sum is 22, and the answer would be n minus 1 since I can remove all the elements, 4. Then I go a bit back and I can say that for the last one, the answer would be 4. I can put it here. And then I go to 5. And at 5, I see prefix sum is 12. I compare it with this number and it is smaller. And this is smaller than that. This is smaller than 20. So I cannot add any elements from the right. I can only add these elements. So for 5, answer would be 3. So I can write 3 in here. Then I move back to 4 and I see 7 as the prefix sum. I compare 7 with the next one and it is greater. So I know I can remove all of these elements and all of the elements which were removed by 5. No, it should be 3. 5 was able to remove all of these elements, and I guess the prefix would be same. The answer would be same. if I can remove the next element, because 5 would have all of these numbers plus itself, and when my prefix sum becomes 12, when my score becomes 12, I'll be able to remove the same number of elements. So that is cool. I can start iterating from the end, and I can start iterating from the end, and I will keep an array for the answer. And how do I keep? I would have to keep track of quite a first an array to sort these numbers, then an array through which I would output, like an array which would contain the answers, and then another array which would contain this prefix sum. Do I actually have to calculate this prefix sum? Do I have to calculate this prefix sum? Yes, I do have to calculate this prefix sum, because that is what I'm comparing the next element with. So I do have to calculate the prefix sum. So another array to calculate the prefix. So one for answer, one for prefix, one array for sorting, one array for the original input, and I would need one more array. No, I can use the answer array for that. Yeah, yeah, I can use the answer. So 4 arrays. I have created 2. So let's see. I would be able to do this. After this, after sorting, I will start iterating from the end, or I could sort this in the reverse order. This is fine. This is fine. I can iterate from the end. I will go not go with the last element, and 1 is 2, while I is greater than equal to, and do I want to go to the last element? Vi answer size n. Initially everything is 0, and I can make answer n minus 1. The last answer for the last one would be n minus 1, right? And here this I do I want to go to the last element also? Nope. The answer for that would be, yeah, it would be 0 for the last element, and minus minus. This start from the second last element. Okay. Prefix sum. I need the prefix sum after sorting the array. So pref vi pref size n or n plus 1. That's it. I today only I watched a video by Ericto on prefix sums, which was cool. I lower than n, I plus plus, and prefix sum. So a ref I plus 1, ref of I plus 1 equals ref I, the last element, plus the current element in the sorted array. The current element is in A, and the index for that element is the current sorted. I sorted the indexes, so the next index would be SRI, think, and yes, that should be it. A SRI. Yeah, it would start at 0. I would get the shortest element. Yeah. After that, int I starts there. After the prefix sum for the current element, I have to check its value with the next one. So if the current, not the value, but the prefix, if the current prefix of I is greater than the next element, and the next element is a SRI plus 1, a SRI plus 1, If my prefix is greater than that, then answer I equals answer I plus 1. Else answer I equals I. Answer I equals I. Alright? Yep. Answer I equals I. Yeah. If I'm at the fifth element, then I would be able to do that. And now for the output for int I equals 0, I, or maybe in for auto I in S. No, for auto X in answer. Yeah, answer. Cout X with the space, and I would also have a space at the end of the answer, which is bad. Can I remove that? Yes, I can remove that by doing cout answer 0, and instead of this I can start a for loop at 1 I less than n I plus plus cout a space and then the current answer, and then at the end instead of this I can do I do not need a space, I simply need a new line. Run this thing, and if I have to save it first. Okay, I say 0, 1, 2, 3, 4. That is not the correct answer. 0, 2, 3, 4. That is not the correct answer. Why am I getting 0? Okay, am I getting 0 because of that? For 1, what is the answer for 1? For 1, it is 0. Okay, I have to get the index from there first. The indexes are sorted there. Yep. 0th. Okay. So I have to go through the sorted array, find the index in the sorted array where 0 is, and then use that index to find the answer. Ah, shit. Okay. Uh, okay, and also that I can do I in prefix, but I cannot do. I can do answer I. Yes, I can do answer I. All the elements which are smaller than answer I. Yep. If it is equal, if they are equal, then I can remove it still. Greater than or equal to. So if greater than or equal to, that would fix some of the things, but still I would have to fix other things. But no, this is wrong. There is something wrong with this. And I, starting from the end, I also have the prefix SRI. I have their indexes in there, starting from 0 index and prefix I. Okay, prefix 0 is always 0. Prefix I gives me the summation of the I elements, first ith elements, including the ith element. And then I'm comparing that if that sum is greater than or equal to the next smallest element, the next greatest element. If that is, then answer become, yeah, then the answer is whatever the next element is. And if not, then answer is I. Except if the values are same. If I have something like 10, 10, 10, 10, what is then? If I have 10, 10, 10, I sort this thing and I know I can remove all the elements here and the sum would be greater than this. In this 4 for all the 5 elements. Yeah, that is cool. 4 is cool. But if I'm here, then the sum is smaller. Yeah, yeah. Okay, so I can add a test case. If the current element, which is A, S, R, I, if it is not equal to the next element, which is A, S, R, I plus 1. If it is not equal, then do this, except do this, otherwise do this. And if they are equal, then current answer is just the same, whatever is the answer for the next one. This is answer I equals answer I plus 1. And I should see 4, 4, 4, 4, and I do see 4, 4, except for this one. Shit. Which means greater than and equal to 4, 4, 4. Cool. Okay, now all I have to do is change the way that I'm outputting them. Here the answer is correct, but here I should be having 2 3s instead of 2 and 3. Should be having 2 3s, and I'm having the answer equal to 2 in this case. Why? Why? There I had 1, 2, 4, 1, 2, 4, 5, and 20. For 20, answer is n minus 1, which is 4. Then I move on to 5 and I see the prefix sum, which is accumulation of all of these elements till now, which is, what am I comparing the last number with? Prefix I if it is greater than or equal. The answer was 3 for 5, and then for 2, for 4, the prefix sum was 7, which is greater than 5. So I'm not calculating the prefix sum correctly. Initially, I Okay, I0 should be equal to. Okay, I'm not calculating the prefix sum correctly. I0 is 0, so I will like to make that one index. So on the sum of first I elements in the prefix, I go to I plus 1. I should have 3, 3 here. That is cool, but now this one is wrong. Prefix sum is messed up now. 0 and 1, yes. I plus 1 because I is 0 indexed. Prefix 0 would be 0. Prefix 1 would be sum of 1 elements. What is the rating of first problem? And can you give the tips for someone who just started CP and only rating is 820? Solve questions, practice. That is the only tip. Solve questions, practice, and the rating of this problem is 1100. Right? And yeah, solve problems and practice, 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 so that these things come to you consciously, subconsciously. There is something wrong with my implementation. A S R I shit. Okay, I will be moving on to the next question. At level 1200 with school, have I done? I think I've done all the questions at 800, then 900. A few questions remain at 1000 level, but I should have been able to do this. I don't know what is wrong with this. I will look at it later. Right now, I just do not want to look at it. And 1200. But wait, okay. I will do this. Hmm, okay. This fuck, this might be harder. I might not be able to do this. And this is making me afraid, but don't be afraid. Let's go. And here also, I would have to make some changes. Make directory 1200 CD and 1200, and here also CD and 1200. This is the question. Winter holidays are coming up. They are going to last for N days. During the holidays, Monocarp wants to try all of these activities exactly once with his friends. Go skiing, watch a movie in a cinema, and play board games. Okay, exactly once. Monocarp knows that on the ith day, exactly AI of friends will join him for skiing, and BI friends will join him for movies, and CI friends will join him for board games. Monocarp also knows that he cannot try more than one activity in a single day. Thus, he asks you to help him choose the distinct days X, Y, and Z in such a way that the total number of friends joining him is maximized. Okay. Okay. So 3 into 3 into 3, total possibilities would be 29, and 2 seconds. I am given 3 arrays, 4, okay, F 30. Here the maximum is 30, so I will choose at least 30 from at least one of these. And how do I decide that I choose 30 from at least one of these? I sort this thing. Okay, I sort these 3 arrays, and after sorting, if I see a contradiction, then I take 30 from the array in which the second is smallest is the smallest, and which is here. I'm only concerned with choosing 3 numbers. They cannot be on the same date. Yes, the top three. Okay, here the top three are 30, 20, and 10. Here the top three are 30, 15, and 20. Here the top three are 30, 25. So the second smallest here is 20, here is 20, here is 25. So I choose anyone which has a second smallest 20. Okay, so but I want to choose 25 later. So I have to choose 30 from here, 25 from here, and 20 from here. That would be the answer. So I want to choose these three in such a way. Okay, if the maximum overlaps, then the second maximum, I have to go to the second maximum and see its index. The value actually does not matter. The value does matter because I have to output the value, the sum. So in that sense, it matters. I see the maximum, and I am only concerned about the top three. So I will create an array of the top three longest, yeah, three maximum, array of size 3, which would have here 0, 1, and 2, representing the top three elements in the first array. And then for the second one, it would have 0, then 3, and then 2, because that is the order of highest to lowest elements, highest to lowest numbers in this. And in this, it would be 0, 1, 2, because that is the index of the numbers in descending order. And then after getting that array, let's see. Okay, thanks. That is why I felt it too hard yesterday. What that sheet? This is called CP31. You can do that. CP31 on TLE eliminators. And yes, yesterday it did felt too hard, but I feel like I should have been able to solve it. So for each of these, I will make an array 0, 1, 2, and then 0, 3, 2, and then 0, 1, 2. Okay. And after making this array, I have to solve with this, and I will at the end write a sequence of 3 numbers. And what am I looking for? I go and I see their first index. They might overlap, they might not overlap, and if they do not overlap, then I just pick the maximum. Or even if they overlap, I do this. Even if they overlap, I choose the one with the maximum value. Greedy. Will greedy work? No, greedy will not work. Let's say if I had just two activities instead of these and just 2 days to complete them. And let's say one activity has number 30 people, and on the first day it also has, the other one has 29 people available. And then according to greedy algorithm, I would choose this number. But on the second day, let's say here I had 29 and here I had 1. So according to greedy algorithm, I would choose this 30 and then this one. So the maximum people would be 31. But if I were not greedy and I chose 29 here and 29 here, then the answer would be much higher, 58. So I cannot go on with greedy algorithm. But one thing that I do know is that I would be choosing something from the top numbers. And conflict would only arise if they are on the same day. If they are on the same on different days, then there is no conflict. Here, there is a conflict. And if there is a conflict, then I would do something else. But here there is no conflict. Mm. If there is no conflict, then I can choose the maximum. Shit. Okay, let me think about this for a while. And shit, due to some reason, I feel like my brain is not working, but let me think about this for a while. So I am only concerned with top three numbers from every of these. And let's try to solve first with two elements. And when two elements are given, and what are the possible cases when I'm only taking two top numbers? Case one, top and bottom are shit, but these are also divided in days, right? 30, 29. And if these are top and if there is no conflict, then I can simply choose the maximum number. Right? That is done. So I'm done with this activity. Cool. And the maximum in this and cool. So that is something that I do not have to solve for. But if there is a conflict, let's say like this, that is, I cannot choose the maximum from this and I cannot choose the maximum from this directly because they lie on the same day. Then what do? I go to the second maximum. I go to the second maximum, and the second maximum could lie on the same day or on different days, and their values could also differ. So if this thing, then let's say second maximum for this is some number x1, and for this is x2. And if they lie, if there is no conflict between them, then which one would I like to prefer? If there is no conflict, then I would like to prefer the bigger one. Let's say x2 is bigger, then I prefer the bigger one. And thus I am done with this part and I can go with this. And I know I have the maximum sum, right? Because I got the maximum from let's say x2 was bigger, then I got the second maximum from this and the maximum from this. Or maybe shit, can I just like sort the whole thing, sort three of them and choose all possible combinations and come up with the solution? Shit. Okay, x1, x2, no, but days, yes, I cannot just choose any random number. Days. Whenever there is no conflict, I choose the maximum number, but there is a conflict, I go to the second highest, which I would be choosing. So, so, I would also like to look at the difference, I guess. 30 minus 29 in this case, difference, and now there are a few possibilities. I choose 30, and there is no conflict, let's say here, and then I choose the maximum between these two, which let's say is x2. Then I got x2, which is bigger than x1, and I got 30, the bigger number in these two. But if x1 was bigger, then should I go for this? Because in the first case, I would get 30 plus x2, and this is when there is no conflict in these two numbers. And if there was a conflict, I could either go with this, that is one way of choosing, or with this. And yeah, in two case, and when there is conflict, it is pretty cool to choose. Yeah, shit. So if there is no conflict, then I do this. Then just choose the maximum number and mark it as done. What is the maximum value of n? N can be pretty big. He is going for a long holiday. N is very big. If there are three and I choose one, not making sense. Good day, what is your age? I am learning competitive programming too. That is cool. Hello, and my age is 20 years old. That is good enough. But I am unable to do this. Oh yeah, I want to relax for a bit, and for that, I would be solving some easier problems from this website, which is cool. And what is this website, you might ask? This is a website for in which you are given questions. Go to archive, you are given questions, you solve these questions, and questions you can sort according to their difficulty or according to the number of people that these questions have been solved by, and then see the question, read the question, and either write some program or do anything. Just at the end, enter the answer that you get after solving it, and it might say right or wrong. And one more thing, I guess, that there is also a rating system. I found this website today, so that is cool. I did two questions in this, were very, very easy. And the questions in this website tend to be maths worthy, mathematical questions. And it is also says, says this here. Project Euler exists to encourage, challenge, and develop the skills and enjoyment of anyone with an interest in the fascinating world of mathematics. So this is maths oriented, and I would like to do some questions to just relax a bit. Yeah, because I have to stream for at least 2.5 hours. Six sum, okay. Sum square difference. The sum of these squares of the first, the sum of the squares of the first 10 natural numbers is this, okay. The square of the sum of the first 10 natural numbers is this. The sum of the squares and the square of the sum, okay. Hence the difference between the sum of the squares of that first 10 natural numbers and the square of the sum is this. For the difference between the sum of the squares of the first 100 natural numbers, and then find the sum and square it and find that, okay. Tmx detached Euler, here I was 3 point, no, problem number is 6, problem 6, 6 point CPP, and main, okay, and answer is equals, no, int, or maybe long sum square initially is 0, and long square sum initially is 0, and after that for int I equals 0 I plus plus I less than 100, less than and equal to first 100 natural numbers, so 100 is included. I plus plus, what I have to do is square of the sum, add I, and for sum square plus equals, what do I have to plus? I into I, SQS, and then std standard out, std absolute value of SQS square of the sum. So I have to multiply SQS into SQS S minus sum of the squares. Line plus plus sixth or slash out, and answer this. Should be correct. It is, and I can move on to the next one. Smallest multiple. I see 2520 is the smallest number that can be divided by all the numbers between 1 and 10. What is the smallest positive number that is evenly divisible by all the numbers from 1 to 20? Divisible with no remainders. So just to multiply all the numbers from 1 to 20. And this problem is problem number 5. Very easy. And main, and answer long answer is equals 0. And then for int I equals 1, I less than equals 20. Okay, I just have to find the prime numbers between this and multiply the prime numbers. I could do that manually, but I do not want to do it manually. Okay, let's do this. cons target lim equals 20, cons int lim equals 20, and you go up till limit. And okay, start at 1 and greatest common divisor of 1, and yeah, so uh, answer, multiply the answer by the GCD, uh, uh, diva GCD of 1 and 0 would be 1, right? And so I divided by STD GCD of I comma answer. I have to include STD GCD wherever it is supposed to be, or I could include okay, bits slash STDC. Yeah, cool. This and then CDC out answer blank plus 5 not slash out 0 is crazy. Multiply the answer with this. GCD of 1 and 0 would be 1 because 1 can divide 0. 1 multiplied by 0 is 0. So yeah, okay. Because I am stupid. Now I should get the answer, which is this. And yep, that is correct, which is cool. And I can move on to the next question. It uh, largest prime factor. Largest prime factor of this. The prime factors of these are this. What is the largest prime factor for this number? Okay, it cannot be copied. Okay, 60851, or I can write it here. 60851475143. Copy. Question number 3. N3.cpp const long n equals control O P, and n main here include bits stdc plus product. And fifth, in here I have to find the prime factor for this one, and that would mean iterating answer equals 0, and for int I equals 1, I less than n square root of n, which is std sqr square root of n less than or even equal to n, and I plus plus, and then if there is no remainder of that number with I, and yes, this number itself could be a prime number. which in this case it is not. So I start with 2. I start with 2 and I would like to also keep count of all the number of factors f equals 0, and then start with 2, right? And then if there is no remainder with 2, that is no n remainder with I. That is I is a factor, and shit, it has to be prime. I'm not just looking for factors, I'm looking for prime factors. Shit. Okay. Okay, so every factor that I find, I have to see if it is prime or not. Either I can do that. I guess I would have to do that. And if it is a prime factor, if it is a prime factor, then compare it with the biggest prime factor at this point. So bool is prime, takes in long n, and then end p is true, return p, and for n I equals, start I at 1 and I less than the standard square root of n I plus plus, and less than and equal to, and then here if no remainder, when n remainder I, if there is no remainder, then f plus plus. Now what is f? And f equals 0. Number of factors. Increase the number of factors not just by 1, by 2, because here and the factor on the other side also, plus equals to, and at any point if f greater than 2, then break, and here instead of p, return f equals to. If it is prime, f has to be exactly equal to 2. Now whenever I see a factor, I would check if it is prime, and I would have two factors. First is I. Let's make these long. Second factor would be n divided by I, and if any one of these is, so if is prime, what if I is prime, then answer is maximum of answer or I, and what is the problem in this? No matching because answer is 1. Yeah, okay. And if is prime SS, the second number, then answer is maximum of answer and SS. And this should work. Like plus 3 not slash out, and I do not output anything because I do not output anything. And output 6857. That is supposedly the answer 6857. Let's see. It might be wrong, it might be correct, and it is correct. That is cool that it is correct. I guess a couple of more questions. Largest palindrome product. What does that mean? A palindrome number reads the same both ways. The largest palindrome made from product of two-digit numbers is this. Find the largest palindrome. Okay. Shit. Do I iterate through all the numbers and then check if they are palindrome? Brute force. Is there like nothing else other than brute force? What does multiplying a number mean? Nah, I guess there is no pattern in multiplying. I would have to actually multiply and then check if they are palindromes. Yeah, yeah. I guess there is no other way than brute force in this one. And include bits std c plus dot h and main not this and every three-digit number. With every three-digit number, the smallest three-digit number is 100 and largest is 99. So for int or long int I equals 100, I less than, and wait, they have to be different, I guess, the numbers, or they could be equal. Two-digit numbers is this. So any numbers, it does not say that they cannot be equal. So less than or equal to 999 or less than 1000 I plus plus, or int j equals 100, j less than 1000 and j plus plus, and long p would suffice as an int p is I into j, and shit, instead of this, yes, I can of course I can optimize this. I start from the end, and while I is or greater than or equal to 100, I minus minus, and find I, replace with j, replace with j, right? And this, whenever I see a palindrome, I will step out, and answer is, let's say, initially -1, and bool his palindrome takes in a number n and says if it is a palindrome, and how do I iterate a number? How do I see if a number is a palindrome? Do I convert it into a string? A string s with n? Can I do that? No. How to convert a number to a string C++. String is string and this, and then string to string. Okay, just use the to string function. String s, and s equals string s as, okay, std string s std to string n. Okay, and then I would like to iterate from start to end, and bool p equals true and return p at the end, and for int I equals 0, I less than s dot size I plus plus s dot size divided by 2, and if si not equal to s n minus 1 minus I, if it is not equal, then I would like to do a couple of things. Then p equals false and break, and this after doing this int. Now if is palindrome, what p, if p is a palindrome, then answer equals p, and also break out of this inner loop, and if answer not equal to -1, then you also break and see out answer line plus 4 not cpp not slash out. Segmentation fault. I less than size by 2 I plus plus. Mm, 1100 that. Let's see this. SDC out SI S plan fourth. I do see one number. Why am I getting a segmentation file? To string bool and I. If I is 0, then the next element would be n minus 1 would be the last element minus index of I is cool. Yes. Why is it wrong? As in like segmentation fault wrong. Si not equal to, how can it go out of segment? I created s here and this, and I will always be lower than s dot size divided by 2, and size could be very big or small. Wait, when I do std cout as 0, and a new line. Line plus plus, one flash out. I do get 9, which is what I would expect. So that is correct. And but then I am getting a segmentation fault. Why? I is 0 here, and the length is 1, 2, 3. 6, length is 6, and 6 divided by 2 is 3. So at max, I would go up to 3 I minus 1 minus I. Yes, subtracting I is cool. Subtracting I is cool. Mm, If they are not equal, then break, return P, break if answer not equal to this. And this is the only part, then I am doing anything. And less than, so I will go up to from 1, 2, 0, 1, and 2. And from the other side, since n size is equal to 6, I would go first from 2, 5, then 4, then 3. 3 for 2. Yep. 5 minus 2 is 3. So that is cool. And if not equal, then make P false and break. And I should break. Not I. The loop should break, and I should come out of the loop. Is it? Is it this thing? I don't think that was the problem. Yep. C out R. C out S I. How far do I go? I don't go any further than that. Okay. I is equal to 0. Replace this with 0. Segmentation fault. I was getting 9 as an output earlier. In somewhere around here. Yep. Okay. Replace 0. uh, Find 0. Replace with I. Line of result 9, and then I get a segmentation fault, which means I do not go to the second iteration of the loop. I do not go to the second iteration of the loop. Does it happen because of this? Okay. Shit. Shit. Of course. Shit. Ah, shit. Int size equals s dot size, let's say, and then here is it lower than size divided by 2, and here remove n with sz. Now we are cool. A little mistake. 5, 8. 0085. That is a palindrome. And what do I have to output? And largest palindrome. 58 double double or triple. That is double 0085. Correct or maybe wrong. So that is not the biggest palindrome. Yes, that would not be the biggest palindrome. Yeah, yeah. My optimization gave me the wrong answer. Usually it is this and do not output. Only break here right after because all the other numbers would be smaller, right? All right. Standard max answer RP. Line of flash out 906609. 906609. That is the correct answer. That is cool. And that would also be the end of today's stream. I did fine, I guess. Yeah.